Hello everyone. This is Dr. R. Sasikumar, Professor, Computer Science and Engineering Department from RMDEC Engineering College, Chennai. Today we are going to discuss about distance vector routing algorithm. So what is distance vector routing algorithm? So each node construct an one-dimensional array. There is a vector containing the distance. Here the distance can be called as a cost to all other node. So each node knows the cost of the link to each of its directly connected neighbor. Consider the following network. So you can start from any node. Either you can start from A or B or C, whatever may be, or wherever you want to start, you can start. If it is directly connected, the cost becomes 1. Okay. If it is indirectly connected, initially the cost becomes infinity. If it is a self node connected, the cost becomes 0. Now, how to calculate that initial routing table of all nodes? Okay, this is the given network. So you can start from any node. So the information stored at node, we have a totally 7 nodes starting from A, end with G. So A, B, C, D, E, F, G. Again, the column wise also we have to write that A, B, C, D, E, F, G. Okay, if the one node is connected with another node directly, the cost becomes 1. If the one node is indirectly connected to another node, initially the cost becomes infinity. If it is a self node, the cost will be 0. Okay, so likewise, you can fill the table. So A is connected to A, that is no self node. Okay, so the cost is 0. A to A self node, so 0. A to B, the cost is connected directly, so the cost will be 1. A to C also connected directly, so the cost will be 1. A to D, there is no direct connection, so initially the cost will be infinity. A to E directly connected, so the cost will be 1. And A to F directly connected, so the cost will be 1. And A to Z indirectly connected, so the cost will be infinity. So likewise, we have to fill that another table. Suppose if the starting node is B, then B to B, B to A, there is a direct connection, so cost is 1. And B to B self node, so cost is 0. B to C directly connected, so the cost is 1. And B to D indirectly connected, so the cost is infinity. And B to E also indirectly connected, B to F also indirectly connected, and B to G also indirectly connected, so the cost will be infinity. So likewise, you have to fill that another node. The starting node is C. So C to A, S, it is directly connected, so the cost is 1. C to B also connected directly, so the cost will be a 1. And C to C self node, so 0. C to D directly connected, so 1. C to E indirectly connected, so infinity. C to F and C to G also indirectly connected, so the cost will be infinity. So, and with respect to node D, D to A indirectly connected, so the cost is infinity. D to B also indirectly connected, the cost is infinity. D to C directly connected, the cost will be 1. D to D self node, so the cost is 0. D to E indirectly connected, the cost is infinity. D to F is indirectly connected, so cost is infinity. And D to G is directly connected, so cost is 1. Next, with respect to node E, so E to A, S, it is directly connected, so the cost will be 1. E to B indirectly connected, so the cost will be 0. Infinity. E to C indirectly connected, so the cost will be infinity. And E to D indirectly connected, so the cost will be infinity. E to F indirectly connected, so the cost is infinity. And E to G indirectly connected, so the cost will be infinity. Okay. And with respect to node F, like F to A directly connected, so the cost will be 1. F to B indirectly connected, so the cost will be 0, infinity. F to C indirectly connected, so the cost will be infinity. F to D indirectly connected, so the cost will be infinity. And F to E indirectly connected, so the cost will be infinity. F to F no self node, so 0. F to G directly connected, so the cost is 1. With respect to node G, G to A indirectly connected, so the cost is infinity. G to B indirectly connected, so the cost is infinity. G to C also indirectly connected, so the cost is infinity. G to D is directly connected, so cost is 1. G to E indirectly connected, so the cost is infinity. G to F directly connected, so the cost is 1. G to G self node, the cost is 0. So this is the way to fill that all the table. But with instead of infinity, we have to calculate that distance. Okay. So now this is the first table, initial routing table. From this table, wherever the infinity is there, instead of infinity, you have to calculate the distance between the two nodes. So the next we should know that how to calculate the distance between the two nodes. This is the algorithm. So the algorithm is run by its node independently and asynchronously. So the step 1, initialize or create initial vectors for the node. Either you can start from A or B or C, or likewise any node you can start, right? The initial vectors of the node must be initialized. The distance to itself, the same node distance to itself is what? 0. And distance to all other nodes directly 1. The distance to all other nodes indirectly, that is the infinity number, as we have seen already. Now the step 2. So far, we have seen only that updation table with a value of 1, 0, and infinity. Now, the second step is what? Instead of infinity, we have to update that a new value. So, the step 2, update or improve the vector with the vector received from a neighbor. So, via neighbor node, you can visit that indirect node. So, allows all entries in the vector to be updated after receiving a new vector. Then step 3, end of distance vector. So this is the way to calculate that distance. With the help of its neighbor node, you can visit that indirect node. So you should add the cost 1. Okay. If it is a direct node connected 1, again with respect to with the help of a neighbor node, you can reach that destination node also by adding 1. So this is the way to find out that new value. So in that table, instead of infinity, you can update the new value also. So now I want to show that the routing table of A. So node F, in that previous diagram, F is directly connected to A. So node F tells node A that it can reach node G at cost of 1, because via F the node can reach G. Okay, so F tells to node A, you can reach G with a cost of 1. Okay, so A also knows that it can reach F at cost 1. Now it will add that another cost. So 1 plus 1, 2. So from A to G, the total cost is 2. Initial table, we have mentioned that infinity. Now instead of infinity, we can represent that new value. The new value must be less than that the existing table. In that existing table, we have mentioned already infinity. Now the new updated value is 2. So 2 is less than infinity. Now you have to update that value. So what is the meaning? From A to G indirectly connected, but with the help of update vector routing algorithm, you can calculate that the new value is 2 via the neighbor node F. So now the final routing table of A is A to B directly connected, so the cost is 1. A to C directly connected, the cost is 1. A to D indirectly connected via C, the cost is 2. A to E directly connected, so the cost is 1. A to F directly connected, the cost is 1. A to G is indirectly connected, but via F you can reach G. So A to F, the cost is 1. F to G also the cost is 1. So 1 plus 1, the total cost is 2. So likewise, you have to fill all the table. So the final distance stored at each node, this is the way to generate that this is the way to update all the value. Instead of wherever the infinity is there, instead of infinity, you have to update the new value also. So this is the final distance stored at each node. Okay, wherever the infinity is there, that new value will be updated. So I hope you understand this problem, right? Thank you.